We're going to continue here with learning properties of logarithms. And we have three new rules. We have a product rule, a quotient rule, and a power rule. And before we get into those, I'm just going to skip over here, and we are going to review some properties of exponents. So properties of exponents, we have a product property, which says if we are multiplying two bases, we can add the exponents. We have a power rule, which says if we have an exponential base to a power raised to another power, we would then multiply those powers. And a quotient rule. And the quotient rule is going to tell me if I'm dividing like bases, we can subtract those powers. Okay? We also know some properties of exponents, such as the fact that any base raised to the 0th power is 1, and any base raised to the 1st power is itself. And these go hand in hand with some other logarithm properties. The log, regardless of the base of 1, is always going to equal 0. And when the base and the argument match, your logarithm is going to be equal to 1. Okay, so we have these properties. We're starting to connect how exponentials relate to logarithms. And we have one other property we've been using a lot. We've got our conversion property. And what our conversion property says is I can take log base b of some argument a, having that equal to c, and I can convert back and forth from logarithmic to exponential. So my exponential form would then be b to the c is equal to some value a. And so seeing how this 0th power and 1st power property relate to our logarithms, we should be able to see some similarities between our logarithmic properties, our product, power, and quotient properties of logarithms. So notice this product rule has a plus, the quotient rule has a minus, and the power rule has multiplication. So going back here, if we have a logarithm, base b, of some product, m times n, and m and n represent any positive numbers or expressions, then log base b of m plus log base b of n would be our expanded version. We have spread it out and we've written this product, this logarithm of a more complicated product, as two simple logarithms with a sum between them. And the same goes for our quotient rule. When I have a quotient in my argument, I can say log of the numerator minus log of the denominator. And then when I have a logarithm and my argument is raised to a power, that argument I can put it in front and use the operation multiplication. So it would be that power times the log. Okay, so let's look at three basic examples and then we'll see how to use all of these properties together. So what we're going to do here is we're going to use a single property of logarithms and we're going to express these logarithms as a sum, difference, or product. So here we have an example. Log base b of the product x times b. And what I can do with this is I can look at that x value times that b value, and I can separate this and say, well, this is log base b of the first factor plus log base b of our second factor. And we can take this one step further to simplify, because we know when the base and the argument are the same, that value is going to turn into 1. So here we used our product property. Let's look at another example. Log of 10 over 3. So in this case, we have the logarithm of a quotient of division. And we have a 10 in the numerator and a 3 in the denominator. So I can take this and separate this and write this as log of 10. And because it's a quotient, we use a minus symbol. So that would be log of 10 minus log of 3. All right, so we've applied our quotient property, and we do know that this is a common log. There's no base written, so it's common log. We assume base 10, and log base 10 of 10 is also going to simplify to 1. So this ends up simplifying to 1 minus the log of 3. And then our third property, if we illustrate that with an example, the natural log of x to the p. So looking at this, I have a logarithm and the argument is raised to a power. If I use my power rule of logarithms, that means I can take the p in front and multiply it by ln of x. And this is as far as we can simplify here. We do have two other pretty basic properties, and I don't say that you need to necessarily know them, but you start to recognize the pattern, and they're really helpful when we think about simplifying. The first one we have here is the logarithm of a base raised to a power. And what this says is if I have logarithm base b of some argument b raised to a power, when the base b and the base in my argument are the same, those guys are going to cancel out, and this is just going to simplify to that power x. So an example using this, log base 3 of 3 to the 5x minus 1. And since my bases are the same, we can essentially cancel that and just bring the exponent down, 5x minus 1. Or we might have the natural log of e to the square root of 2x. So now keep in mind, a natural log is log base e of e to the square root of 2x. So again, we see that the logarithm and the exponential are the same base. This is going to just simplify to the square root of 2x. And further, I'll just do one more of this type example. We could have log of the cube root of 10. So log of the cube root of 10, that's a cube root, but a cube root can be written as a rational power. So this is the same as saying log of 10 to the 1/3. So keep in mind, this is a common logarithm. This is log base 10 of 10 to the 1/3. And because my base on my exponent and my log are the same, this simplifies just to 1/3. So I had three things I could simplify there. And one other simple property which makes sense, it's basically the same as what we just talked about, but in a inverted form. We have a base to a logarithmic power. And so it says the same thing. If I have some base b within the power, I have a logarithm of the same base. Again, the log and the exponential base are going to cancel, and we are going to be left with just that argument. here. So an example or two of this, we might have 3 to the log base 3 of 8x minus 11. And so because I have base 3 exponent with log base 3 in the power, those are going to cancel, and my answer is just 8x minus 11, the argument of that logarithm. Or e to the natural log of 5 minus x. So e and natural log are the same base. This simplifies to just 5 minus